Okay, so we're going to start lesson 2 today. Lesson 2 is on quadratics. So we are working on quadratic equations. Quadratic equations. That is where we are starting today. So if we are doing quadratic equations, what does that mean the largest power is we're going to be working with? 2. So quadratics always have to look like this. Ax squared plus bx plus c. Okay? Quartics are fourth power, but quadratics have to be the highest power they can be is 2. Okay? So in this lesson, we are going to talk about the different ways to solve quadratics. Okay? We're going to look at different ways to solve quadratics. And what we're going to do is I'm going to give you a problem, and we're going to solve it all 3. There's technically 4, but algebraically we're going to solve it 3 ways. Okay? So when you're doing a quadratic, okay, so methods to solve quadratics. And again, I said we have 3. There's technically 4, but we're going to focus on 3. What is the way that we spent a ton of time on so far this year solving quadratics? So factoring in general, right? Okay. Most of the time you're going to use AC method, go through, do grouping, and solve that way. Factoring to me is probably the most time efficient way of doing it. But I know some people aren't a fan of factoring, so we also have other methods. A secondary method is the quadratic formula. Okay? Which is the opposite of b, plus and minus the square root of b squared minus 4ac all over 2a. That's quadratic formula, which hopefully you remember that from geometry or algebra 2. You probably did it quite a bit in geometry as well. Yes, Luke.
Does that work on every problem?
Quadratic formula?
Yeah.
Quadratic works as long as you have a, b, and c values. There are certain, I won't say it works every time, but it does work most of the time. Sometimes your answers aren't as user-friendly, but yes, quadratic should work every time. Keyword there being should, not does. The third one is completing the square. This is probably the one that you're least comfortable with. We're going to spend some time here today and tomorrow reviewing that. Completing the square was the one when I learned these in Algebra 2. Our teacher mandated that we did a whole unit only by completing the square, and I hated it. Absolutely hated it. Now, it's helped me now because I now know better ways to teach this because I had to learn those ways to do it. But to me, I avoid completing the square as much as I possibly can. Okay? And then the fourth way, you can solve it is graphically. And when it's asking you to solve and you're trying to look graphically, you're looking for x-intercepts. You're looking, where does my graph cross the x-axis? The problem with that is, do all quadratics cross the x-axis? No. So if it asks you to solve and find exact solutions, you try and graph, and both solutions are imaginary, you just did all that work to find out, oh, hey, I know I have 2 complex roots, but now I have to go back and do one of the first 3 methods to find those 2 complex roots. So it's one of those tricky things where that's where I say we're going to focus on the first three. Graphically is always an option, but graphically is also one of the more simplistic methods. Are you making fun of my chicken bracket?
Yes.
Okay, so first thing I want to do is review how to do completing the square. Okay, first thing we want to do is review how to complete the square. All right, first rule with completing the square. To complete the square, it again has to be in this form. We call that general form of a quadratic. It has to be in general form. Okay, if it's not in general form, you're in trouble. You got to put it in general form before you try and use any of these three methods. Now, do these both have to be plus? No, but it has to be in general form. So rule number one is make sure A equals 1. If not, divide everything by A. Okay, completing the square only works if A equals 1. So if A is not equal to 1, it becomes problematic. So if A is not equal to 1 and I say you must use completing the square to complete this problem, you have to divide A, B, and C all by A. And then that makes A 1.
Even if it doesn't go in.
Yes, then you leave it as a fraction. Yep. Which is part of the reason completing the square gets ugly, because if A is not 1, and then you end up with B as a fraction, well then you're having to square and multiply by a fraction, and that's just, it gets ugly. But it is a valuable tool to have. So, we are assuming now A is equal to 1, we're in good shape. Okay? We now have to move C to the right side. So your equation should look like this. X squared plus bx equals negative C. Okay? Everybody good? And I know this isn't going to make sense just going through the steps, but we'll hopefully be able to do this and get an example in before the class starts. Third step is to make the left side a perfect square. Okay? So we want to be able to write the left side as x squared plus bx plus c. And I'll show you what I mean by that. How do I make the left side a perfect square? I take b divided by 2 and square it, and then I add that to both sides. So you take the b value, whatever the middle is, you divide it by 2 and square it, and then you add that to both sides, left and right side of your equation. Step 4. Factor the left side. To x plus b over 2 squared equals c form. So we have to factor the left side to a perfect square, which it should be now. 5. Take the square root of both sides. And 6. Solve for x. And it should always have 2 solutions. Should always have 2 solutions. Okay. Now I know, just looking at those steps, that probably doesn't make sense. I promise you, going through completing the square, it will make sense. All right, we're gonna do a really, really quick example here.
What is that thing?
Where?
On the bottom.
This, that's solutions. That's just writing it shorter.
Abbreviation.
You good, or do we need more time? All right, quick example. Stick with me here. This is probably gonna run right up to the bell. All right, so we're gonna take the example x squared minus 6x minus 16 equals 0. And we're gonna solve that by completing the square. Now, some of you might be able to look at that and know right away that that factors, because it does. I understand. This one's actually solvable by all 4 methods, which is why I'm choosing to show you this as our first example. So, first step, make sure a is equal to 1. Is a equal to 1 in our example? It is, so we're good. Step 2, move c to the other side. Well, how do I move c over? It's negative 16, so how do I move it to the right side? Add it. So I get that. Now notice, I leave a hole in there. Reason I do that is the next step is to take my b value, which is negative 6, divide it by 2, which is negative 3, and square it. Negative 3 times negative 3 is 9. And then I add that to both sides. Everybody with me? Okay. Now I need to factor the left side. So I know this is x, I know this is x. I need 2 numbers that multiply to 9 and add to negative 6. 3 and 3. So it's x minus 3 times x minus 3 equals 25. But what do I notice about those 2 factors? They're the same. So I can write it like this. X minus 3 squared equals 25. And that's the form I said I wanted as a perfect square. Well, now it's a perfect square because both sides I can take the square root of. Next step, take square root of both sides. Square and the square root do what on the left side? They cancel. On the right side, whenever I draw the square root, what do I have to put in front of my answer? Plus or minus. That's really important because, again, that's the only way you're going to get 2 solutions. Then I add 3 over, so I get x equals 3 plus and minus 5. And again, you should always have 2 answers. Your first answer, 3 plus 5 is 8. Your second answer, 3 minus 5 is negative 2. There is how you complete the square. Again, we will pick up with more of that tomorrow. Please have your 4-1 homework done tomorrow. I will walk around, make sure it's done. I will take questions if you still have some. Is there anybody that needs to come in during green time today? Keaton? Fire?
Can I
Yep.
come in here?
Yeah.